Hello everyone. In this video, I'm going to go over a couple of examples straight from your homework. I've copied and pasted question number 2 and 10. This is from your total and net ionic equation worksheet. So let's get started. Question 2 is barium chloride and sodium sulfate. So they're asking us that to provide three different things: a molecular equation, a total ionic equation, and a net ionic equation. Right? They've given us only the reactants, and we have to begin to then figure out what kind of equation, rather what kind of reaction this is. So let's start. We begin with what we're given. So let's write that down. Barium and chloride. Now barium is, I'll toggle screens here to a periodic table. Barium is in the second group of the periodic table, right here. That means it's a +2 charge, or has a +2 charge. Chloride is a halogen, has a -1 charge. That means we're going to need 2 chlorides, or 2 chlorine. Let's go back, trying to be neat here. Okay, right, and we don't know the state yet, but we're going to figure that out using our solubility rules, which I'll toggle to in just a bit. Okay, plus, so I'm leaving a bit of space here. Sodium sulfate. So, and I'm also leaving some space for coefficient because we have to balance that too. So sodium sulfate. Now sodium has a +1 charge and sulfate has a -2 charge. So we're going to need 2 sodiums for that one sulfate. And we also don't know what the state is. We can safely assume, I think, that it's going to be 2 solutions, 2 aqueous solutions, but let's use our solubility rules to practice that. Okay, so let's space here and reaction arrow, and that's going to produce something. Now this is where we have to then figure out what kind of equation, rather what kind of a reaction this is. So it appears to look like, in its standard form, so if barium is A, chlorine is B, sodium is C, sulfate is D, that looks like the general form of a double displacement reaction. So let's do that. That means barium is going to pair up with sulfate and sodium with chloride. Let's write that down. Barium, sulfate looks like this. Right, now it looks like this, exactly like that. We don't have to put any subscripts here because barium has a +2 charge and sulfate has a -2 charge, and they are electrically balanced. Plus sodium chloride. Leave some space here for coefficient, sodium and chloride. We only need one of each because sodium has a +1 charge and chloride has a -1 charge. Okay, now we have to go to our solubility rules. So let's do barium chloride first. Barium chloride, I'm going to toggle over to solubility rules right here. So this is the worksheet where I'm getting these questions from. Okay, so barium chloride. Let's find the rule that talks about chloride ions. All right, chloride ions looks like it's number 4. So it says chloride, and these other ions here, we can ignore those because it's not relevant. So chloride ions form compounds that have low solubility with silver. Remember, it's paired up with barium. So silver, lead 2, mercury 1, copper 1, or thallium. Barium is not on that list. So if it's only low soluble, or rather forms precipitates with only these ions, and because barium is not in that list, that means it's going to be soluble. So we can go back to our sheet here and write, since it isn't soluble, we're going to write AQ, since it is soluble, since it is not going to form a precipitate, we write AQ. Okay, according to rule number 4. Sodium sulfate. And we're going to go back to our solubility rules. We're going to look for a rule that talks about sodium or sulfate. Here we have sulfate ions form compounds that have low solubility with calcium, strontium, barium, radium, and lead ions only. Lead 2 positive ions only. So sodium is not in that list. That means it is going to be soluble. So we write AQ. Good. Barium sulfate. Let's look that one up. Sulfate again. But this time it's paired up with, you can see, barium, and it says sulfate with barium does form a precipitate. So we write solid. Sodium chloride, going back to our solubility rules, chloride only forms compounds that have low solubility with silver, lead 2, mercury 1, and copper 1, and thallium. Sodium is not on that list. That means it will not form a precipitate. It's going to then be AQ. Now this is what's called a skeleton equation. The Skeleton's equation is complete, except that it is not balanced. So let's balance it. Okay, we have barium here, one barium there. Fine, we can leave it alone. We have chlorine here, chloride, and two of them, and only one here. So let's put a 2. I'm not looking at answers in front of me. I'm just working through it myself, as you might at home. Okay, so that's changed number of sodium, but it's fixed chloride. But look, it's actually changed for the better, because here we have 2 sodium ions on the reactant side. So that's actually worked out well. We balanced barium, chloride, and sodium. What's left is sulfate. Sulfate's right here, one of each. It's balanced. So this is now the answer to the first part. Our molecular equation is now complete. Next, total ionic equation. Now this can get a bit messy. Let's do that. So this is our molecular equation. Our total, I'm going to call it total ionic equation, looks like this. Everything that says AQ, here, here, and here, you have to break apart into its ions. So it'll look like this. Right, there's just one barium. Don't forget the charge and AQ. There are 2 chlorines or chlorides, each one with a -1 charge, and they're all aqueous in solution. Sodium, there's 2 sodiums, see that subscript there? Each one has a +1 charge, and it's aqueous. Then we have 1 sulfate, right? That is also aqueous with a -2 charge. Okay, reaction arrow. Barium sulfate, because it's solid, we leave it alone. This one's aqueous. Taking the 2 into consideration, that coefficient, we have 2 sodiums, each one with a +1 charge. And I'm going to move over here now. And we also have, because of that coefficient affecting all of sodium chloride, which includes both sodium and chloride, we then have 2 chloride ions, each with a -1 charge, and they're all aqueous. Okay, now that is our total ionic equation. Next is our net ionic equation. Here's where we can go back and take a look. What appears on both sides? Barium, barium ion. One barium ion is here, none here. We leave it alone. 2 chlorides. That's it. There's one here and there's one here. We can cancel those out. There are 2 sodiums, 2 sodiums. We can cancel those out. Okay, so what we're left with is 1 barium, 1 sulfate to produce barium sulfate. Good. So our last part, after we've done total ionic, we're about to do net ionic, is then barium plus, all we're doing is rewriting this, sulfate, that's a Q, not a G. And that's it. And this is our final answer. Don't mind that scratch over the 2 there. That's our final answer, and that is 2. Okay, gonna start 10 now. Let's see if I can manage to find a way to scroll down a bit here. Okay, good. We'll start it up here, over here now, and I'll scroll down. Okay, so 10. You have sulfuric acid, that's H2. SO4. We know that all acids are aqueous, so we don't have to look at our solubility rules for that. Potassium hydroxide. There's potassium, there's hydroxide. Potassium is a +1, hydroxide -1. Let's look at our solubility rules. We're looking for potassium or hydroxide. Hydroxide's right here. Okay, so it says hydroxide ions form compounds that are soluble only with positive ions listed in Rule 1 and with strontium, barium, radium, and thallium. Okay, so potassium isn't there. So let's go to Rule 1. Let's see what's in Rule 1. Look, potassium's in Rule 1. That means it is soluble. Switching back. We can then write AQ. Now, again, a double displacement reaction, because of the same reason, it follows that general form. We have an A, we have a B, a C, and a D. So we're going to get H from here with OH, in other words, water. Now, you may have realized earlier that this is a neutralization reaction. This is an acid and this is a base, so we're always going to get water, H2O, and a salt. And salt in this case is going to consist of potassium and sulfate. Potassium, though, has a positive 1 charge. Sulfate has a -2, so we need 2 potassiums. Sulfate is here, and you'll see that this is going to be aqueous as well. Okay, we can double check. Let's go to solubility rules. Sulfate ions, remember it's potassium sulfate. Sulfate ions, rule 5, form compounds that have low solubility only with these ions here. Potassium is not on that list. That means it is soluble. Okay, so this is our skeleton equation. We now have to balance it. So let's do that. Let's begin with sulfate. Sulfate here, one there, that's fine. Potassium, there's 1, there's 2 here. All right, let's put a 2. Okay, we fix potassium. Let's look at our hydrogens and oxygens. There are 2 oxygens, right? Not the ones included in sulfate, but there are 2 oxygens, so probably have to fix that. So let's put a 2 there. Then there are 2 times 2 hydrogen, that's 4. Let's look at our hydrogens. There's 1 hydrogen here, but because of the coefficient there are 2. So 2 plus the 2 here is 4, and we're balanced. Good, so now we have finished our molecular equation. We're going to now do our total ionic equation. So total ionic equation, everywhere that says, I missed something. Let me finish that sentence though. Everything that says aqueous needs to be dissociated, ionized, and I'm going to write that in our total ionic equation. I'm missing a state here. H2O isn't aqueous because anything that is in H2O is aqueous. Water is actually different. We don't write aqueous, we write L for liquid. Continue to follow the same rule. That is, anything that has AQ gets broken apart. Right, I'm going to write that out now. Oops, mistake there. Let's erase that. Right, there is no, I'll erase that plus sign too. It's not H2, right, because there are 2 ions of hydrogen. It's just that. Let me write AQ. Okay, there's 1 sulfate there. Don't forget the charge, right, -2. Because of this coefficient, there are 2 potassiums and 2 hydroxides. Plus 1. Plus 2 hydroxides with a -1 charge, reaction arrow. And here, all you do is you write 2 H2O, right? You write exactly as it appears. It doesn't change because it is not aqueous. Then we have 2 potassiums and 1 sulfate. I'll just write that down here. 2 minus or -2. And we're done. Okay, before we write our total, or rather our net ionic equation, right, we have finished our total. We're just going to look through this and cancel out whatever appears on both sides. Okay, so hydrogen ions, 2 of them, they don't appear on both sides. Sulfate does appear on both sides, 1 there, 1 there. 2 potassiums, yes, 2 potassiums right here. 2 hydroxides, no. So let's scroll down a bit, and we're going to finish this question by writing the net ionic equation. Just copy down whatever's here minus whatever's canceled out. So and you're done. Right. That is it for questions 2 and 10. Continue practicing, and we'll see you next time.